Hello. We will explore the topic of energy, meteorology, and technology. Weather plays a major role in how we produce and consume energy. A cloudy day reduces solar power, strong winds can halt turbines, and droughts can limit hydroelectric energy. In this presentation, we will dive into how weather affects renewable energy and how technology helps us adapt. When we talk about renewable energy, there are three main types we focus on: solar, wind, and hydroelectric energy. Each of these sources comes with its own advantages, but they are all closely tied to weather conditions. Let's take a closer look at each of these and see how weather plays a role in their efficiency. Solar energy production heavily relies on sunlight, but weather conditions like clouds and extreme heat can significantly reduce its efficiency. For example, when temperatures hit 40 degrees Celsius in California, solar power output dropped by 15%. Cloudy weather can reduce solar panel efficiency by up to 50%. Additionally, extreme heat increases electrical resistance, leading to lower performance. That's why it's crucial to keep solar panels clean and well-maintained to maintain their efficiency. Wind turbines perform best when wind speeds are between 7 and 25 meters per second. If there's not enough wind, no power is produced, and if the wind is too strong, turbines will shut down to avoid damage. So, wind energy relies on finding that sweet spot in wind conditions for optimal performance. Turkey has made remarkable strides in wind energy in recent years. In 2023, Turkish wind farms generated over 30 terawatt-hours of electricity, which covered more than 10% of the country's total energy needs. Thanks to advanced weather forecasting and smart grid integration, Turkey has been able to maximize the efficiency of its wind power. Offshore wind farms are in a unique position, benefiting from more consistent wind conditions than their onshore counterparts. But the trade-off is that these farms need much stronger structures to withstand the harsh weather conditions of the sea. Take, for example, the wind farms in the North Sea. They provide a significant amount of energy to Europe. Hydroelectric plants are deeply influenced by rainfall patterns. Consistent rainfall is essential for maintaining proper reservoir levels, so when rainfall is low, energy production can drop significantly. On the flip side, excessive rainfall can boost energy production, but it also comes with risks, like flooding. A good example of this was in 2021 when Brazil faced a severe drought, causing a 30% decrease in hydropower generation. Weather forecasts are key when it comes to planning renewable energy production. Short-term forecasts, like predicting wind speeds or solar radiation, help improve efficiency and allow operators to quickly adjust to changes. For instance, when wind speeds drop, wind farms can shut down turbines to avoid energy loss or damage. Similarly, forecasting cloudy weather helps estimate solar panel efficiency more accurately. Long-term weather forecasts look at seasonal changes, which can have a big impact on renewable energy production. Things like rainfall or snowmelt can directly affect how well hydroelectric plants work. These forecasts help predict future energy production and any potential imbalances. For example, during the winter months, snowmelt can raise water levels in hydroelectric plants. With this kind of forecast, dam management becomes much more efficient. Smart grids are advanced systems designed to balance energy supply and demand. By integrating real-time weather data, these grids can instantly respond to changes in energy production. For instance, if wind speeds drop, the grid can activate stored energy to ensure a steady supply. If weather forecasts predict a drop in wind speeds, the smart grid can store solar energy to be used during times when wind production is low. Smart grids don't just react to weather changes, they also plan ahead. For example, if a storm is forecasted, the grid can switch to alternative energy sources to ensure a continuous supply, preventing interruptions or power outages. A great example of this is Denmark, where the smart grid successfully balanced wind and solar energy, preventing power outages during a storm. This shows just how effective smart grids can be in managing energy efficiently. Looking ahead, smart grids will become even more efficient and will drastically reduce energy losses. With technological advancements, they'll integrate even more weather data, allowing them to adapt faster to environmental changes. For example, Japan is working on enhancing its energy systems with advanced smart grids to minimize the impact of storms. These smarter systems will be more resilient, helping to reduce the effects of natural disasters. Smart grids not only optimize energy production, but also help ensure a more sustainable use of renewable energy. By adapting to fluctuations in energy production, they provide a continuous and reliable energy supply. For example, in Spain, smart grids help balance fluctuations in solar energy, improving the overall sustainability of energy production. In this module, we've explored how weather plays a critical role in renewable energy production. We've seen how tools like weather forecasting and smart grids help manage energy production and increase efficiency. Accurate weather predictions and smarter energy management are not just about advanced technology, they're essential for creating a more sustainable future. Thank you for listening.